So today we are going to solve the problem of finding floor in a sorted array. We are given a sorted array and an integer x. We have to find the index of the zero based array of the largest element in the array that is less than or equal to x. This element is called the floor of x. If such an element is not present, we would be returning -1 as our answer. In case of multiple occurrences of the floor element, we would be, it's not ceil, it's floor of x. Yeah, so in case of multiple occurrences of floor of x, we will be returning the index of the last occurrence. So this is a point to remember. We are given array 1 2 8 10 10 12 19 and the target element is 5. So what is an element in the array which is just smaller than or equal to 5? So 1 is smaller than or equal to 5. Okay, this can be a possible candidate. Coming to 2, 2 is also a possible candidate which is less than equal to 5. Now coming to 8. Yeah, 8 is greater than 5, so our answer would be 2, since 2 is the smallest possible value, which is 2 is the largest possible value which is just smaller than or equal to 5. And since 2 exists at index 1, we would be returning answer as 1, which is the index of the element 2. Now coming to the second example, the given target element is 11. Now let's see if uh, how many possible candidates are there. 1 is a floor element of 11, it's correct. 2 is also a floor element of 11, correct. 8 is also a floor element of 11, correct. Now there is also 10, which is also a possible candidate. This duplicate 10, which is the multiple occurrence of 10, is also a possible candidate. So we would be returning the last occurrence, since there are two tens, one at 3 and one at index 4. So the question asks us to return the last occurrence of the floor element if there was multiple floors. So we would be returning answer as 4 in this case. And for the third example, since there are no element smaller than equal to 0, so we would be returning -1 as our answer. Now let's see how we would be approaching this problem. Uh, the floor can be found by just simply iterating over the array and taking in account of the elements which are just smaller than the target element x. So we would be iterating with 0 index, where this was the case, and we stored answer as 0. Going to the next element, we stored answer as 1. Going to the third element, we stored answer as 2. Now 10, which is also a floor element of 11, so we stored answer as 3. Going forward, there also exists another 10, which is a floor element of 11, so we stored answer of 4. Since there are no more elements left for us to there are elements but they are not possible candidates, so we would be returning the last occurrence, which in our case is 4. So since this is a linear scan and the time complexity is O of n. Now can we do this problem in a better time complexity? If you would have observed carefully, the arrays are sorted in ascending order, or you can say it's non-decreasing order. So we can think of a binary search approach here. Let's see how the binary search approach uh, would work. What if we assigned low and high pointers, and each time we would be iterating over the array, we would be finding the mid. Since we found we let's say we got mid at here. Now since 10 was possible candidate, which can be floor element of 11, we stored answer as 3. Let's also mark the indices 6. Now where we should go, or where we should search such that we get a floor element of 11. Since 10 is a possible candidate, so it would be feasible to discard the elements at mid -1, that is in the lower search space. Why? Since we are asked to get the highest possible value, which is just smaller than 10, so it won't be feasible to search in the lower search space, because every element is now would be smaller than 10. So we can discard the left half, and we can proceed by moving the lower pointer to mid +1. Now if we find again mid, so mid is found here. Now, is 12 a possible candidate? No, it's 11, that it's greater than 11, so it's false and it's not a possible candidate. So, would it be feasible to check in the higher search space? No. So, we would be discarding this and moving the high pointer to here. Now, there is only one element left, 10, at index 4. So, since 10 is also a possible candidate, so we can store answer as 4, which is the index of this 10. Now since there are no elements to check for, we can safely return answer as 4. So this is how the binary search approach would work. So let's code this approach. So we are in our code editor. Let's mark the low and high pointers. Also, let's make a variable answer, initially assigning it with -1. This would be to store the possible index of the floor element. Now let's run a loop where low pointer would continue until it's less than equal to high. Also in the meantime, we will be finding the mid index. Also let's store the current element, which is the element at mid index. So now let's check if the current element is smaller than equal to x, so we can safely store the index of the current element, which is mid, and we can try to get the highest possible. So highest possible we can get only when we can move toward the higher search space, so we would be moving the lower pointer to higher search space, else we would be continue to search in the lower search space, and finally we can return the answer. So let's return. So this was the overall code, so let's check. And as you can see, the first test case passed. Let's also check for the remaining test cases. And yeah, it passed all test cases, and this is pretty efficient, which is a logarithmic time complexity, and we also avoided to do it in linear scan. So in the interview perspective, uh, going through and explaining your approaches and optimizing it further can really benefit you. So yeah, this was it, and I hope to see you soon.